My name is Badesh Ray, and I'm a rising sophomore in high school. Um, so today is going to be a video on recursive complete search. So recursive complete search problems are just complete search problems, where you have to look through all of the possible cases of like a solution and find the optimal one. But instead of like a basic iterative like search, like a basic iterative search, basic complete search, you're gonna use recursion. So I've gone over basic complete search before, and you just usually you're gonna have some sort of iterative process to find your solution, use some for loops or something. But recursion is gonna be a little bit different. So recursion is basically the recurring call of like a function to itself. So how it works is you're gonna have like your code, you're gonna have some function that's gonna help you find your answer, and you're gonna call the function on itself like repeatedly in order to find all the cases. So that's kind of what a recursive complete search type of problem is. So yeah, it's just like kind of like a basic introduction to recursion. Uh, and recursion can be used for many other things too, but this for now is just today's over complete search. Okay, so now you know what recursion is. Um, let's see how to apply it to this problem. So this is an easy problem that I got off of useful guide. Um, and yeah, you can find it there too. So the problem is pretty simple. You just have they give you a number n, which is the number of apples, and then the next line is like an array p, which is the weight of each apple. So you just have to split the apples into two groups, uh, and you have to make sure that, or you have to try and minimize the difference between the weight of the groups. So yeah, either n apples with known weights. Your task is to divide the apples into two groups so that the difference between the weights of the groups is minimal. So for this sample test case, they said that one of the possible groupings was to have group one with apples 2, 3, and 4. And obviously 2 plus 3 is 5, 5 plus 4 is 9, and group 2 is 7, weights 1 and 7. So 7 plus 1 is 8. So one group has 8 and the other group has 9. So the difference is 1. And that turns out to be the minimum possible like difference. And yeah, so how do we use recursion with this, right? So first you have to think about like how would you go about choosing for like a certain apple, which basket would you put it in or which group? So let's say you have two baskets, so one basket for each group. Okay, so 1, 2, and then we're gonna have some apples. So let's use this for example. So you have one apple of weight 3, one apple weight 2, 7, 4, and 1. So now what you have to do is think about this, okay? So for each apple that exists, how many options do you have? What can you do with it? Like regarding which group it goes to. You have two options, right? Because for a certain apple, you could either put it into group 1 or you could put it into group 2, okay? So let's say you're at the first apple. There are two choices that you can make. First choice is to put this apple in group 2, and the second choice is to put the apple into group. Sorry, the first choice was to put the apple into group 1, and the second choice is to put the apple into group 2. So now you made two choices. So if you make those two choices, now your possibilities split off into two. Okay, because before you selected any apples, you you were only along like one path, right? You didn't really start anything, so you didn't really have multiple paths that you were looking at. But now there's two decisions that you can make, and you want to make both of those decisions, right? You want to go to group one. You could also want to try if you go to group two, because remember this is a complete search problem, so we're gonna try every single combination of decisions and try every path to find our optimal answer. So what happens is, let's say we're following the path of you chose to put the apple into group one. Then from there, you continue on kind of, okay? So let's use this as like a connecting choices, okay? So you did this option where you put the apple into group one, and now your path continues on to uh group two. Sorry, not group two, the second apple, right? Now you can choose to put the second apple into group one, or you can put the second apple into group two. So again, you have two choices, right? So initially we had two choices for apple one. We could put into group one or group two. We said if we put it into group one, then we have to go and choose make the same decision for the second apple. For the second apple, we can also put it into group one or group two. So it turns out that like basically at each step, you're gonna try putting an apple into group one and group two, and you're gonna follow along those paths and then make that choice for each one and keep going until the very last apple is put into either group. Okay? So now the last thing we did was put the second apple into group two or group one. So we have to choose, right? So let's say we put it into group two again, or sorry, group one again. Okay. So then now we have to continue on to the third apple, right? Now let's say that maybe we put this over here into group two, right? So that's a certain path. But then what would happen is if instead we followed along that path of putting the first apple into the first group and the second apple into the first group, and then instead of putting the third apple into group two, if we put the third apple into group one, that would be a different path that we're following, right? So we have to trace all of those paths. Um, and what happens is, like, when we're at the very end, after we've chosen the group for the final apple, we're gonna have two groups that are decided, right? When we're at the end of a certain path, and we just have to see the difference and return that difference. Um, and we're gonna compare that with like a lot like other values because obviously we're gonna be going through a lot of different paths. So um, yeah, you just have to choose the best one out of all those, all like out of everything returned from all those paths. And we're gonna have a bunch of paths because that was just like one example of a path, but like we're gonna after the third apple we have to choose for the fourth apple and for the fifth apple. They all have two choices, so there's gonna be many paths that we have to follow. Um, I think for this you basically have like since you have two options for the first apple, two options for the second apple, and so on. You basically have two options for every single apple. So it's gonna be like you're gonna have to follow 2 to the power n paths. So n is if n is the number of apples, you're gonna have like around 2 to the power of n paths that you kind of have to follow and see. So yeah. Okay, so now that we understand like the process of how we can do it, let's see how we can put it to code. Okay. So first, let's just kind of look at like summarize our solution, right? So our solution is we have a list of numbers and we have to split it into two groups, right? We already know the problem statement. So you have two options for each number to put into the first group or the second group. We have to pick like one of those two options and like you have to go through all the combinations, like trace all our paths by go to the next number, choose one of the two options, go to the next number after that, choose one of the two options, and um go on like that. And we have to choose like one of the two options to follow a certain path, but we're technically going to be choosing both options because we're going to trace all the paths. But for a certain path, you have to choose one of the options. So and trace every path like that. So let's see how we can put it to code. Okay, so here I just have um like the basic layout to like begin coding. I just have my main function body and some headers. Um yeah, and I have some comments here for writing our code. First, let's begin with our input. So on and a key. So yeah, we'll just take input. Okay, so now we've taken our input. Um, Now we just have to call, like, remember, we need a function, right? So before we do anything else, we need to do our, like, function. So let's say, remember, our function has to return a number, right? It has to return the minimum difference between the weights of the groups. So, look, since we're learning recursion, let's just call it, like, recursion, okay? Like, it's a recursive function, let's just call it that. So, okay. Now what we have to think about is when we're going to call our recursion function, what are we going to call? Um, what we have to call is we have to give it like the position in the path we're at right now, right? So we kind of have to know how many apples, or not how many apples, but how much weight do we have in the first group and how much weight do we have in the second group, right? We have to know that to make any decision during our time. Sorry, not to make a decision, but when you get to the end of the path, you have to know the weights, right? Because that's how you compare the difference and return the difference. So we always have to know that, right? The weights of each group. And we also have to know the position that we're in the apple array, right? We have to know which number apple we're at because that's the apple we're going to make a decision for, and that way we can access like the weight of the apple, right? So if we choose to put it into group one or group two, that's what we're gonna add to group one or group two. Um, so yeah, that's turns out to be all that you need for the parameters of this function. So you're gonna have the weight of group one, the weight of group two, and the index that you're at in the like, apple array. Um, and yeah, so we're also gonna need the array, the apple array, and like the number n, because like that's what we're gonna know. Like we're gonna know the bound, right? N is the bound. We don't want to go past like n apples or anything. And then we have to access the weights. So let's actually make these variables global variables. So we'll just put so we'll just define them up here basically. Because if we define them in here, then they'll only be accessible in the main function uh, unless we pass it into the recursive function. But it's just easier to make it a global variable than make it a parameter. So now let's just take out the that over there, and we'll say p equals vector size n. Okay, yeah. And then once we take our input here in the main function body, obviously we want to call our recursive function. So initially we're going to be having 0 as the weight in group 1, 0 is the weight in group 2, and we're going to be on the 0th index. We're going to be using 0 indexing, right? So the 0th index is just going to mean that we're at the first end. Okay, so now uh, once we're over here, so I have some comments here for writing our function. Um, so yeah, let's just like look at the comments, right? So when we're at the end of a path, we have to return the difference between group 1 and group 2, right? Remember, that's what we were trying to find. We're trying to find the minimum difference between group 1 and group 2 when we split the apples into two groups. So that's like what we have to check. Remember when I said we don't want to go past like the nth apple or anything, right? So before we do anything inside of the function, first we want to check what apple we're at because we don't want to go past the last apple. So basically, um, if IDX is equal to n, right? So because um, if IDX is equal to n minus 1, that means we're at the last apple, and we have to decide if we want to put it into group 1 or group 2. But if IDX is equal to n, that means we've already decided between group 1 and group 2 for the last apple. So our path is finished, and now we're at the step after the path where we're going to return like the difference. So if IDX is equal to n, return the absolute value of the difference between group 1 and group 2. Okay? So I'll repeat myself once more. If IDX is equal to n minus 1, then you still have to make the decision to put the last apple into group 1 or group 2. So you're gonna keep going. But if IDX is equal to n, that means you've already decided if you want to put the apple into group 1 or group 2. So now you just have to return the difference between group 1 and group 2. Okay? So um this is basically what we would call like our base case, right? Our base case is when we know like we're returning some sort of concrete number, right? The concrete like that's group 1 group minus group 2. Like we don't know what exactly group 1 and group 2 are. Um but those are two variables that we're going to return the difference of. That's something like we know like is going to happen at the like after the end of the path. Okay? So yeah, the base case where n minus 1 is the index of our last apple, right? So I already explained this. N minus 1 is the index of your last apple, and n is like after you've decided everything, you've finished the end of the path, and now you just have to return the difference. Okay, so now once you're done with your base case of returning the difference um, at the end of the path, now you want to do like your recursion, right? Because remember, this is a recursive function to find all the different paths. So remember when we drew out like the apples and stuff when we were trying to figure out the solution? Remember, we were branching off into two paths, right? For a certain apple, you could put it into group 1 or group 2. So all you have to do is do that, like make both decisions, right? So for one decision, what you would do is you would call your recursive function on g1 plus p of index, okay? So if you do g1 plus p of index, this means that you're adding the current apple to the first group. Okay, so that's one of our possible decisions. So g2 would stay the same, and your IDX would update, right? Because you're going to the next apple after this. You've added the current apple to one of the groups, and now you're going to the next apple. Okay, and you would also do the same thing, but for the second group, where now you have G1, G2 plus P of IDX, and then IDX plus 1. Okay? So you're going to call the recursion function by making both of those decisions to add the apple to the first group, to add the apple to the second group, right? Um, And so now you're not just gonna call the function because if you call the function, if you don't do anything with the value that's returned, then it doesn't matter, right? So we have to return something from here, okay? So what we're gonna return is remember when we call these recursive functions, as they split off, as they get to the end of the path they follow, you're eventually gonna get to the base case, right? The base case will return the difference of the group 1 and group 2 at the very end of the path. So that means that these two functions, like these two function calls, are going to return something eventually, right? They're gonna keep following, keep making splitting off into new paths until they reach the base case, at which point they will return, and at a certain point they will return to this specific function call. So you're gonna have two differences to choose between, right? Each function call will return a difference of group 1 minus group 2. So you have to choose between them. Which one are you going to choose? You're going to choose the minimum difference, right? So what you're going to want to do is return from here the minimum difference between the two returns, like the two things that are returned, right? So yeah, you call the function twice, making both decisions adding to group one or group two. Then you choose the minimum uh, between those two differences, and you're going to return that minimum. Um, so yeah, and then this is pretty much all you need to do. Uh, so when you call recursion on 000, just output whatever that returns. Because like even when you call this initial function call, that is gonna eventually get to this, right? Like it'll have this going on, and eventually the two function calls that it makes will eventually reach the base case and then start returning back up to here. And so eventually you're gonna have to, it'll return this like value, the minimum between its two differences that has to choose between. So yeah, just see out that, just output the return value of this, or not the return value, but the whatever this returns, and then yeah, and a new line for formatting maybe. So that's all you have to do, and now we can try and run this for the sample input. So just give it a second. Um, yeah, so that's like recursion, right? Like there's just basic recursion. So remember the definition of recursion was like a recurring call of like a function to itself, kind of. So you saw like when we came into here, when we initially called this recursive function, we came into the recursion function that we made, and here we're calling the recursion function inside of the recursion function, and it does it again and again until it reaches a base case, at which point it starts returning. Um, so yeah, let's try that, and we get the output of 1, which does match up with the expected output. So let's try and submit this. Submit and use file. So yeah. Okay, yeah, and our solution got accepted for everything. For yeah. Um, so yeah, I hope that was helpful and like that helped you understand what recursion is. So just a simple problem over recursion where the function is calling itself again and again. It's a complete search because it's going through all the cases, right? Um, it's just splitting off into multiple paths, trying every path. Every path will return something, and it just chose between whatever all those paths returned. So yeah, I hope that was helpful, and I'll make more videos in the future. Thank you.